Hi everyone, this is a kind of an optional video to watch. It's reviewing what we did from this lesson here, and I know that we were doing a lot of work with converting from polar to rectangular coordinates or rectangular coordinates to polar, and I just wanted to let you know that it is possible to check your answers with using a calculator. So if you have a graphing calculator, you can check your answers by using these features. So I'm going to use the same exact problems that we did in the lesson video from before. So you'll get to see the same thing here. So for polar to rectangular, you can use this in your calculator. Just change it instead to, you're going to need to make sure that this is in degrees. So make sure that's in degrees here. And then you're going to go here where it has the apps key. You're going to get angle here. So you'll have to use second function and then go to angle. Okay. And then notice here you have R to PR, R to P theta, and then P. By the way, P is representing polar, R is representing rectangular. And then you have RX, so you're trying to find the X coordinate. If you're given the polar coordinates, you want to find the Y coordinate, that's what you use. Okay, so to find, I have polar coordinates 20, 150 degrees. I'm going to go here. Use polar to rectangular for the X coordinate. I'm going to input 20. I had to put in comma here, and then 150. So the calculator already knows that I'm putting in polar coordinates for here, as long as I put parentheses, have comma to show the separate values, and then I have a close parentheses there. So I have over here negative 17.32. What I had over here is negative 10 square root of 3. I can just put this here, and then I can see that it's going to be the same value. So that is the value that I had too. Okay. For the Y, we're going to do the same thing. We're going to go over to angle, and then we're going to go down to polar to rectangular. Oh, I went too far. Okay, here we go. Click enter, and then I'm going to put in again 120, comma 150. Oh, excuse me, not 120. So I can just delete that one. So delete. Okay, and then 150, close parentheses, and I have 10. All right. For the other example that I did with going from rectangular to polar, I'm going to go back here again, and I'm going to use these features here. So rectangular to polar, finding R, the radius. And I'm going to input negative 12, just make sure you're using the correct key for the negative sign, comma, negative 9, close parentheses, and I have 15, which is what we found over here before. And again, going back here to theta over there, I could just click 6 to get that same function, okay? And I will put in again negative 12, comma, negative 9. And I get negative 143.13. Now that's interesting. I didn't get it for that one. So I wonder what happened then. So let's see. It's true that I have with negative 143. I think what it's noting here, because negative 143 degrees is the same as positive 216.9. So it is taking into account by the fact that we had a negative inside of here. So if you wanted to get the positive direction for that, then it would be 216.9 degrees. Just remember that you could find that by finding the coterminal angle with that. So 143.1, and I would add 360 degrees to that. So it's the same as subtracting from that. So if I go back to my calculator and then subtract that, or if I add that same value, and I could do second function answer from before, and then I can click enter. So it is 216.869. So that was going to be rounded up. Okay. Now, why show the calculator if you're or why go through the work if you know you can do it on the calculator? Just notice that in the example that I did before, this one was convenient to be able to do without needing to use any kind of calculator. It was you were able to just use the unit circle just to be able to find those values. Using a calculator can be helpful if you were say that you didn't have special angles for that. So in this case, for this one, theta was going to be 36.9 degrees. So it's not a special angle on your unit circle, so that would be pretty difficult to be able to find in there. And then same thing, say if you had polar coordinates where the angles weren't special angles, then of course you would want to be able to check with your calculator and see what you have. Okay, so I want you to be able to use this as a tool to double check your work. And just let me know if you still have questions about these kinds of problems. Continue practicing, okay?